begin with the machine learning project, which I was the project lead for. And we built a tag annotation tool with machine learning. And moving into our agenda for the day, we'll have proper introductions of our team. I have two of my teammates here. We are going to move into the project definition, the problem statement, and how we thought we were going to deal with that, the architecture that we used, the project execution in terms of the steps, exact steps chronologically we took to execute this project, our comments on what could be possible future work for the product that we made, and then we'll open the floor for some questions and answers at the end of it. Okay, so my name is Saad Tariq. I introduced myself briefly at the start. I was the project and the product lead for this machine learning product. I'm currently a master's in industrial engineering student at New York University. And I would like to introduce my technical lead as well, because he was a huge contributor as a part of this project. His name is Soumya Goswami, and he is currently a PhD student in electrical and computer engineering, while also getting a master's in data science at the University of Rochester. Sai, would you like to introduce yourself?
Sure. Hello everyone, I'm SaiLikhith. I'm studying second year Masters in Computer Science from NYU.
Perfect. And Wen?
Hi, I'm Hui Wen. I am a junior studying math with minors in computer science and data science here at NYU as well.
Perfect. And we also had our teammates Shalini, Saad, and Karandeep, who are also huge contributors to this project at different stages, who could not be with us here today. So moving into the project definition, the problem that was given to us at the start of the project was it was open-ended, and what we knew was that we want to improve the tagging that exists on the STEM-Away forum. And over here, what we can see on the slide is an example of, on the top is an example of bad, what we would consider not good tagging or bad tagging, where it's not defined and there's only one tag. And on the bottom half of the screen is what we consider as good tagging, or what was the desired level of tagging we wanted on the forum. And why there were tags missing was there's a couple of problems that fed into why we were not getting the tagging behavior we want on the forum. So if you can see here on the right, this is the mechanism, or this is the interface when you make a new topic or new comment at the forum. This is the interface that you have to deal with. And we identified three major problems with the current system that was in place for the tagging. The first one was that there is no algorithm, or the algorithm is very inefficient to predict tags. So there is actually no model that takes into account what the user is writing. So the user just has to go and pick relevant tags from a list of all available tags. Hence, being said, the interface does not encourage tagging. There are no recommended tags for the users over here. And the last problem that we identified was that the new user fed tags, or the new user comments, they are not used to improve any model or any system, which we think is key, because STEM-Away is it's already exploding with new comments and self-assessments and topic titles coming in every day. And we feel like we should use that new information to keep improving our models. So given this problem statement, we came up with our product requirements at the start of the project. And what the product requirements that we set for ourselves were, we're gonna have actually build a model, a machine learning or deep learning model that's going to recommend relevant tags, not a whole list of tags. And as a benchmark, we're gonna say that it's gonna have an accuracy greater than 70%. The next thing we said for ourselves is we're gonna have an annotator tool. So something that actually prompts the user to put the tags in instead of them looking for them in a list. And the third thing was these new comments plus tags that we're encouraging the user to select. We want to use them for our future work. So we're gonna integrate active learning as a part of this project as well, and as a part of this product. So now I'm gonna show you the product architecture diagram, and I think it's necessary to show this in the start, and we're gonna discuss each of these individual steps as part of the presentation ahead as well. So the user journey starts at a user comment, which is a part of our annotator tool. A user puts a comment in an annotator tool, which is fed as test data to our model. And we'll discuss what these models look like and how they work. So the model then predicts a number of tags for a user fed comment and shows it to the user as a part of the annotator again. So now the user who's written a comment and he's getting 10, 12 recommended tags, he can choose from them. He's like, I only think these 4 are relevant for the post that I'm making. So he writes his comment, chooses those tags, and within our system, there is the new user comment plus the tag annotated. It gets stored into a buffer database that we made. And this buffer database is actually very key to the active learning that we set up. And we're going to talk about this in further slides as well. But this was the basic architecture that we made and the basic diagram that we worked to expand our product off. Moving forward, we're going to move into project execution, and my wonderful teammate Hui Wen's going to take it away from here.
Thanks, Saad. Okay, so the first thing we needed for the project was to actually get some data which we can train our models on. So as a group, we chose to scrape our data from the Stack Exchange forum. This decision was made from a few considerations of factors. So first of all, Stack Exchange is a very widely used forum. It has a large user database with various posts in a large number of categories which are very relevant to the STEM-Away forum. Second of all, we observed that this Stack Exchange forum is very well annotated. They have tags that are relevant for each post. And adding on to that, there is a voting system on the platform, which further gives these posts and its tags extra credibility and tells us that it is indeed relevant. And lastly, seeing as Stack Exchange has a decent or a good tagging system, we thought that we would want the STEM-Away forum's tag recommender system to model the same type of behavior as what we see on Stack Exchange. And so considering all these options, we made our choice to move on with this. So in this next slide, you can see a sample of like a data point that was collected, shown in this table above. For each post in the Stack Exchange forum, we collected the topic title, the content, and all the tags that are associated with the post. As a group, we managed to scrape a total of 60,000 data points from the forum. And from those 60,000 data points, we obtained 480 unique tags that were related to machine learning. However, we did consider that, and we thought that predicting 480 tags from 60,000 data points would be challenging, and some of the obtained tags were less relevant than the other tags to our specific use case, which was the STEM-Away forum. So because of that, we chose to reduce the number of tags we would like to predict from 480 down to 25. And these 25 tags were chosen based on the frequency that they appeared on the forum, and also the relevance of each of these tags to the post that we would normally see on the STEM-Away forum. And so reducing this number of predicted tags made our project a lot more manageable. And so with this, we could move on to the next step, which is building a model, and I will pass it back to Saad.
Perfect. Thank you so much for that, Hui Wen. So now we're going to move into the modeling approaches and how we evaluated these models. So when I was given the problem statement, we really went back, did some research, me and the technical lead, along with our team as well, on what the tagging problem is outside of the scope of our project as well. And we found out it's still very open-ended, with people coming up with new and creative solutions every day, you know. So me and my tech lead, we thought it best to make our own solution for our problem instead of taking somebody else's solution. So we sat down and we thought about it. And once we had reduced the tags from 480 to 25, we thought it was best to make it a multi-label classification problem, because doing a multi-label classification with 25 classes is a lot easier to do with higher accuracy than it is to do with 480 tags. And what we had to do to build a model like this was, there's basic two-step approaches that two steps that we needed to do. We had to transform our comments and topic titles into vectors, or into numbers that the computer can understand. And this is what people call natural language processing. And we did it using two different ways. We used the BERT model that's made by Google, and it would give us a vector of 768 attributes. or we could use TF-IDF vectorizing, which gave us actually a good control over the number of features we wanted in our for our comments. And what we did for the tags were we made a tag vocabulary list, and this tag vocabulary list was one hot encoded for every comment. So this comment with 768 features or 4,000 to 6,000 features for the TF-IDF would individually get mapped to its own to its tags for its vocabulary list. So in this example, for let's say number one, we can see that machine learning and reinforcement learning is a tag. And down below in the dictionary, we can see there's 5 tags in total. So for topic content one, only the machine learning tag and the reinforcement learning tag is one hot encoded, whereas the other ones are left as zeros. So this is how we made our multi-level modeling or mapping approach for this problem. So moving on, what kind of different models that we use? There's different models we can use to classify, and there's different ways we can create vectorization for our topic contents as well, right? And we came up with 3 basic models that all of us tried. The first one was BERT for vectorization of the topic content, followed by feed-forward neural network for classification. TF-IDF, the second one was TF-IDF was for vectorization, and the feed-forward neural network for classification. And the last one that we tried was TF-IDF for vectorization and logistic regression for classification. And there are pros and cons to all of these. Some being that BERT gives you a limited number of features, whereas TF-IDF gives you a range of features where you can choose whether you want 3,000 attributes or 6,000 attributes, and that does have an effect on accuracy for our model. Whereas on the classification side, a feed-forward neural network would take a longer time to train and a longer time to predict, whereas logistic regression would take a smaller time, but the accuracy might not be as well. So there are some trade-offs for each one of these models. And we're going to look at how we chose these models based on the metrics that we wanted to evaluate. And the metrics that we looked at for each model was the precision of a model, the recall score of a model, and the F1 score of a model. And what precision does is the precision penalizes the tags that should not have been labeled, but they were labeled as part of a prediction, whereas recall penalizes tag that should have been labeled but were not predicted. And it was confusing for all of us in the start for when we started doing multi-label classification, like what does this mean in our case, you know? So if we look at the bottom half of the screen, there's a beautiful example that just illustrates what a true positive, true negative, false positive, and false negative would be in our multi-label classification approach. So given we had this very simple topic title, which is better, machine learning or deep learning for classification, and all the tags that were available to predict from. We can also see the actual tags that were predicted by our model, which was machine learning, deep learning, classification. So the actual tags are the ones that were actually associated, the machine learning, deep learning, and classification. Whereas the model predicted the tags, machine learning, classification, clustering, and statistic from the vocabulary list. So on the matrix here on the right, we can see which ones should have been predicted, which are being the false positives, clustering and statistics. Then we have the not predicted, but should have been predicted, the deep learning. And this is how we build our metrics for model evaluation. Moving forward, now we can actually see what the evaluation looked at different probability thresholds. So we see that BERT gave us a good precision at higher thresholds, but like the recall score and the F1 score really just fell down, you know. And the TF-IDF model was overperforming the BERT model. It was doing a better job, even though that we assumed that BERT was going to give us better embeddings because it was contextual embeddings. But the TF-IDF model was, because we could control the feature size on it, we got a better model. We selected the number of features, optimized number of features to give us the best performing model. And that gave us a higher accuracy than the BERT model. And if you can see at the bottom half of the screen, the TF-IDF model plus the logistic regression one was the one that was doing the best job. But we really couldn't use it, you know, because it had limitations in what it meant for the project. And what it would do is we would have no control on the number of tags that were being predicted by this model. Sometimes it would predict 2 tags, sometimes it could predict 8 tags, and we were not okay with that for the scope of our project. So moving forward for our project, the model that we finally chose to work with was TF-IDF for vectorization and neural networks for the classification. So now we're going to move into project execution, and I'll pass it back to Hui Wen to talk about the different prediction methods that we used.
Thanks, Saad. Okay, so now that we have decided on which prediction model we were going to use, the next step was to decide on how our model would actually predict the relevant tags. So how our deep learning model worked was that when a user inputs a post, the model will give us a probability of whether or not each of the 25 tags would be suitable for that given post, with 1 being the most suitable and 0 being basically not suitable at all. And after obtaining these probabilities, we had 2 ideas as to how the tags could be predicted and outputted to the user. And these methods will be explained in more detail in the following slides. So our first method we tried was by using probability thresholds. How this works is that we would set a threshold at which we determine would be like a good indication that a tag is relevant to a post. For example, if we set the prediction threshold at say 0.5, all the tags that were given a probability of 0.5 and above from the deep learning model would be predicted as possible tags or relevant tags for the post, and while everything below 0.5 would not. So intuitively, as the prediction threshold increases, the number of tags that were predicted by the model decreases, as can be seen in this chart shown in the slides. And we found that this was actually giving us an issue, because if we set the threshold too high, the prediction model only gave us a very low number of tags. For example, if you look at a chart, from about 0.7 and above, the average number of tags predicted for each post is only about 1. And what's even worse was that the one tag that was predicted is usually really broad, such as machine learning or Python, which did not actually give us sufficient information about the post itself. On the other hand, though, if we lower the prediction threshold, we would encounter cases where there would be an overwhelmingly large amount of tags predicted, and that number was very hard to control. And we also found it really hard to check how relevant each of those tags are, because they might give us 15 tags and there was just no clue as to how relevant it actually was, and we did not want the user to browse through 15 tags to be able to tag their post. So that leads us to our next prediction method, which is the n most likely tags method. So I think this method is pretty self-explanatory from the name. Basically, it would output the top n tags with the highest probability values as the predicted tags to the user. And we implemented it that the tags would be shown in descending probability order, so that the most likely tags would appear first to the users. In this slide again, you can see one of our instances, and so in our instance we chose the number to be 10. And so this is a sample of the 10 tags that were predicted for a particular post, again listed from the most probable to less probable as the list goes down. And we like this prediction method because I think it gave us a sense of control and consistency as to how many predictions a user will actually see every time they make a new post. And to add to that, by sorting these predictions in descending probability order, we will make sure that the users would see the most relevant tags first without having to browse through a really long list to actually get a sense of what tags are relevant. And so with this, the prediction model has been decided and we were ready to move on with the implementation. And so as mentioned, after that, the deep learning prediction model and the prediction method was pretty much done. And so the bulk of kind of like the back-end work for the recommender model was completed. And this is just an example of a very scratch, like finished product of our recommender model. And so this slide shows a sample user input post with the topic title and the topic content. And so when we get a post like this, our recommender will take that post and then predict the 10 most likely tags that will be relevant to the post. Again, listed from the most likely to less likely as the list goes down. From that, the user can select and input the actual tags that they think are relevant to the post that they just wrote. And these newly inputted posts and tags by the user would then actually be put back into like a database for further active learning by the model to improve our tag recommenders performance like in the future. And I will pass this to Sai for more explanation on that active learning loop.
Thank you, Hui. So now that we had built the backend model, and in order to scale it for any real world application like LinkedIn or any forum that has a huge number of posts, it is not always possible from our end in order to throw a recommender and to predict for unknown category post as well. So we took advantage of active learning here. So active learning is a process where we give a chance for user to label our outputs and send back into the system for retraining in order to improve our accuracy. So what we did here is like we predicted the top n suggestions for a post, let us say top 10 suggestions, out of which user selects the 4 or 5 relevant tags he thinks that are more relevant for that particular post. So that will be taken as an input for us, and we store that input and retrain our model in order to improve our accuracy. Well, you can see that architecture here. In the right side of architecture, you can see active learning loop, where we show the predictions out of which the user will be annotating them, and that will be sent back into our model where we retrain it. But how efficient is it to retrain it for every new input? Is it possible for a real world scenario? No, I don't think so, because we have a lot of social media or any forum websites that have tons and tons of posts. And for every new post, if we want to retrain our model, that would be super inefficient, considering that we had a lot of GPUs involved and the computation cost is going to be more. So how we faced the challenge? So we took the advantage of having a buffer. So we created a buffer database kind of thing in order to store the top, the first 50 inputs and batch process it. For every new 50 inputs, we batch processed it. And later we can scale it up depending upon the flow and the traffic involved in the website. We can still scale it up, but that is a concept which we used is like buffer, where we batch process it for every k inputs so that we can improve the algorithm efficiency in terms of time complexity. So that is how we took advantage of it, and this proved wonders for us. This active learning essentially improved our performance. So you can see that in the visualization, where before active learning the accuracy stabilized around 79 kind of thing for test accuracy for unforeseen data. Whereas after active learning, for very small input number, like for 50 new inputs, it improved till 81, which is very good considering the real world scenarios. And for huge number of new inputs, it is going to be improving a lot and stabilizing at a better position. And that is how we made it, ensuring that this model works perfectly in considering the scalability part and the reliability part, because we are taking the user inputs back into our system and retraining them. So it will be highly scalable and highly reliable. So how to make this model an end-to-end solution? So now that we created an entire backend of it, we thought of creating a UI for it in order to show it to user. Instead of talking about the programming part, we would like to make sure that it is like a product which can be usable. So we try to deploy it into Streamlight and make it into a user-friendly thing in order to make sure that user can see it, what is actually happening there. So in the next slide, I'd like to show you how it looks. So you can see that the user initially gave the inputs in the left part of the slide, where our predictions are there, the top 10 predictions which appeared for that particular part on the right side of the slide, out of which the user selected 4 to 5 relevant inputs you can see that the highlighted in the pink color, out of those will be sent back into our system as inputs from user, and we will be putting that into our active learning loop, and we'll wait for every k new inputs and batch process it every time, so that by retraining we can improve our accuracy. So this is how we tackle the problem, and we can also suggest how this end-to-end tool can be beneficial for STEM-Away platform. In the next slide. Yeah. So if you can see now, the STEM-Away being a new platform and growing platform, there are a lot of posts which are untagged, and there is a lot of unforeseen data till now. So in order to make sure that we cannot tag everything manually, that's not possible. So we can try our algorithm, because it is trained upon Stack Exchange, where we have tons of data and tons of tags which are relevant to almost every field of a computer science, or be it bioinformatics. So there are a lot of data which is available from Stack Exchange. So we train that algorithm, and also we are using active learning from it. So that would be highly reliable and highly scalable, considering the ever-growing platform like a STEM-Away. So we can actually try this for predicting the new content and the existing content and giving some tags for it. Over to Saad.
Perfect. Thank you so much for that, Sai. So now that we have shown the backend work and the user interface on how we deployed it, let's consider what would be our conclusions and where do we see this product going into the future. So given the product requirements the project statement that we had in the start, the project requirements that we came up with in collaboration with stakeholders and mentors, in the end, we were able to propose a machine learning model with a really high accuracy for predicting tags instead of the user choosing tags. We made an annotator tool which made the tagging or which encouraged tagging behavior. Instead of people looking down drop down lists, it actually popped the most relevant tags for you. So we actually made the annotator, and then we actually integrated the active learning loop. We were using all the new comments that were written by users with their tags to retrain our model time and time again to improve our accuracy. And we, as Sai mentioned, we improved our accuracy from 79 to 81%. And that's the only slide we could generate, because I remember at the end of our project, when we were just playing around with it, we had increased its accuracy to around 85%. And that was not that, and we're still anticipating more improvement with the additional data coming in on the STEM-Away forum. So that's like a huge success for us, benchmarking our performance at 70%, and then having a model that was giving an accuracy score of around 85%. So in conclusion, we were very happy with the model performance and the product that we made. But what could be possible future work, right? And we really thought about this problem like, it was like we're the ones who are going to solve it for the whole world or something. And we were trying to get into the complexities of it by the end as well. And there were a few things, like even though we had a model that would predict for us, there were a couple of things we felt like that could be improved. Right now, we were constrained to a 25 tag list, or a 25 tags per pathway. STEM-Away has different pathways, bioinformatics, machine learning, user interface, user experience, and there we restricted ourselves to 25 tags for each of them. We want to improve this, like users would say things that might not be in the tags, and what kind of things would be predicting then. And what we thought was we can set up a deep learning model that can actually go through the new content that a user puts in inputs, and then has a way of looking at the content and suggesting new tags. And in addition to the 25 tags that we already have in the list, we should have the ability to suggest the new tags given the content that they feed to our model. And Sai is going to talk about the next two ones because it was his idea.
Sure. So initially we proceeded with Streamlight considering the user friendliness of it. But I believe that for future purposes, I can go for Flask instead of Streamlight, considering the lot of customizations it offers for complex UI processes as well compared to Streamlight. So the other thing which we are trying to focus upon is like, there are a lot of users that will be suggesting different tags for the same context that we already see every day in social media. So we are trying to see how our model behaves for user-based variation effect, that we would call it like that, where for the same content, they're trying to give different tags. So in that case, how effective is our active learning loop? That is what we want to focus upon. And that is what we have been trying upon to improve our accuracy time and again. So these are our future works, and over to Saad.
Perfect. Thank you so much for that. And that is the end of our presentation. I'll open the floor for question and answers if there's any. Pratik, this is towards you. We would love to get your feedback.
Actually, I was taking notes, and first thing that I wanted to mention, I'm not just a cliche dishing out compliments over here, but I really appreciated how really articulate and very clear and concise each of you were. That is amazing. I really appreciate that.
Thank you.
I do have a few questions that are let me pose a few of them that are in increasing order of openness. The first one is more of a comment. So you have this model accuracy prediction slide. That is a few slides back. Yeah, we just crossed that.
This one.
No, it was
the visualization part.
That's right.
Active learning. Okay.
Yes, this one. So here is an example where it is really important in almost all presentations. Once you put two slides that are next to each other side by side like this, the y-axis should be on the same scale. If you put them above and below, the x-axis must be on the same scale. But ideally, both the axes should be comparable if these graphs are sort of comparable. You are, of course, using the same colors and so on and so forth. So that's just a comment. I could ask questions related to the actual findings and techniques, but I wanted to ask you, when you came from 480 possible tags to 25 tags, how did you choose these 25? What kind of analysis went behind choosing these 25?
You can speak to that.
Okay.
So,
yeah, we chose those 25 tags depending upon STEM-Away based relevant tags as well as the top predicted tags. So it is like a combination of top, let us say we want to generate 25 tags, out of which it is a combination of top 10 to 15 tags based upon the frequency of it, and also the relevant tags, especially for STEM-Away, because STEM-Away has some leadership aspects as well. So we combined those both in order to get an efficient bunch of the relevant 25 tags, which we feel those are explicitly for STEM-Away.
So you hand selected some of the tags, is that right?
Yes. So
yes,
we initially just shortlisted what I would say around 40 tags based on the frequency of tags, because we wanted to have a huge data set, because we were shortlisting from the 60,000 data points that we initially collected. And from those 40 tags, we realized that not all of them are going to be relevant to the pathway that we were trying to apply this on. So, and this was done in collaboration with other teams who were working on building the same kind of product. We sat down with our mentors and we decided that these are the tags that we want to have on this part of the forum.
Okay.
So, yeah.
Okay. Sounds good. There are technical issues behind that, of course, because the most likely tags are not necessarily the most informative tags.
There was a huge data class imbalance problem, which was related to the machine learning tag that we had, and that's where we couldn't do the probability threshold prediction type, because if we only got one tag as a prediction, it would 90% be machine learning.
Yes.
And we knew that there are techniques to improve data imbalance, but the information that we would be creating the new information out of was also imbalanced. So like, even if I created new information, it would have still been imbalanced, so we just stuck to the data that we had and worked with it.
Yeah, so there are things that you could think of over here. in terms of the most informative set of tags. So if you have CNN in there, maybe machine learning is not something that you want to include based on your data set, of course, right? If you have CNN, then deep learning is probably not what you also want to include, because there's so much overlap between them. Maybe just choose deep learning and drop CNN and so on and so forth. So there are issues of that sort that you've definitely started looking at. So I understand you were aware of these issues. Slightly more open-ended question. There are two places where you showed diagrams of how you would architect the system. One was for active learning. The other was right at the very beginning. You were showing how the whole process would work. Did you consider the risks of designing the system this way? Are there other alternate designs that you considered and then discarded?
No, since we made the system from scratch, this was the one and only system that all of us could come up with for this problem, because we wanted to solve this problem uniquely for ourselves. Yeah, so this was what we thought was the perfect system for this problem.
Okay.
Yeah.
And I can perhaps highlight a few possible risks to think about over here. You are taking tags that are predicted by your system and making it extremely easy for users to select a few of those tags.
Yep.
That over the course of time is going to bias your tag set.
Yep.
And that is a distinct risk, which might ultimately, it has the chance of turning your tag set to something that is completely pedestrian and not very useful.
Yep.
So that's one of the risks. So this is something that is always worth thinking about. How can you make it very easy for users to actually say that I don't agree with any of these. I want my own tags, and actually reward them for that. Sorry, somebody was speaking.
Yeah, I would like to add a point there. So in order to tackle it, what we tried initially while web scraping is like, so you're talking about a scenario where user don't want any of the predicted tags, right? So there can be a customization which can be extending the user input along with the predicted tags. I mean, he can choose either any of those 10 tags, or he can write his own tag that will be, I mean, going into the system for retraining. So that is one thing we tackled it. I mean, we're trying to improve the accuracy for it. The second thing which we tried to having more reliable data is like we went to Stack Exchange, and while web scraping only, we took the most voted inputs, and the most voted inputs, we assumed that would have a relevant tags attached to it. Otherwise, people would be putting dislikes to it. So that is a strategy I would say we followed in order to get, I would say, reliable data. So what we did was like we filtered by most votes and get the relevant data, that because we felt like the most voted data definitely will be viewed by a lot of people. So if that is not relevant, they are going to punish it. So in that strategy, we try to make it as reliable as possible. But yeah, we'll consider these points to improve it further. I think, yeah, these are relevant.
And as it stands, it seems like your project is already very useful. So these are not critiques to your project, but in the spirit of the discussion today, these are the kinds of things that we have to think about when we design systems, because we have to think about systems that we want to design that will outlive us. I might design a system, I might improve it for a couple of quarters, and then I might move over to a different group. But this piece of software is going to continue to run on our servers, serving this purpose. So these are the kinds of things that we have to discuss. And this is something that we constantly challenge our colleagues, and our colleagues constantly challenge us. Just blindly walk into a room and say, what are the alternate designs? It's a very useful question, even though it's a dumb question, just a very useful question. It forces the other people to think about it. So having said that, I really enjoyed all of your discussions over here. and we could talk at length about the technicalities of some of these. I think that there is perhaps a little bit improvement that you could have made on the active learning side of things, because the active learning part is just taking in, it seems to me, all the labels that the user chooses and retrains with that. But the point of active learning is to be probing about the tags that we are least confident about. So if we know, if we are pretty confident that the tag CNN applies to a post, giving that to a user is not as valuable as giving, say, I'm not quite sure, it feels like birds should apply to this post, but I'm not feeling very confident of that. The value of user input over there is way more. And that is where the information gain is maximal. That is, it appeared to me you may not have considered that in your active learning system, but that is one of the core tenets of active learning, why people want to use active learning.
Perfect.
Sure.
Prateek, thank you so much for that feedback, and it was nice to be on your challenge side today instead of your teammates. I think we're all learning a lot from it, and the risk part and the second thing that you mentioned about active learning, I feel like moving forward, if I ever have a chance to work with this product again, those are the things I would begin with, given that we have the current architecture.